fell on the ground. What is this?
This is bricks. Bricks are usually used in massive construction like walls and pavement.
Oh, why is so hard? What is made from?
It's made from sand, cement, aggregate.
Oh, is it some test to know this is cement or not?
Yeah, of course. That we explain to you. Yeah.
Assalamualaikum warahmatullahi wabarakatuh. I am Amir Fidah bin Muhammad. Number metric is 2025-862-126. Today I want to talk about brick. A brick is a type of building material used to build wall, pavement and other elements in masonry construction. Properly, the term brick denotes a unique primary composed of clay, but is now also used informally to denote a building unit made of other material or other chemically cured construction block. There is many functions of brick. One of them is construction of wall of any size and construction of floor. There is 5 types of material used for brick. One of them is engineering brick, sand lime brick, and common burnt clay brick. What is brick made of? As you can see, there is silicon dioxide, aluminum oxide, lime, iron oxide, and lastly, magnesium oxide. There is 2 applications of brick as construction material. One of them is wall, building, and road pavement. There is 2 lab tests I want to show you. The first test is hardness test. We just need a hammer and brick. We take a hammer and smash the brick really hard. As you can see, the brick failed the test. The brick is broken. The second test is water absorption test. We need a brick and a container. We put a brick in container for a few hours so it can soak water. So we can see the brick passed the test. Okay, that's all. Thank you.
Hello everyone, today I want to talk about advantage and disadvantage of brick. First of all, we are going to talk about the advantage of brick. The first one is durability and longevity of brick, where brick structure are very strong, resisting high wind, heavy rains and general wear, often lasting centuries with little degradation. Other than that, bricks also are fire resistant because bricks are naturally fireproof, offering excellent fire safety for buildings. And lastly, bricks is energy efficiency because they absorb and release heat slowly, keeping interior cooler in summer and warmer in winter, reducing energy costs. Then we are going to talk about the disadvantage of brick, where brick is a higher initial cost because bricks are generally more expensive than material like concrete blocks due to raw material, manufacturing and transport. Then, bricks are labor intensive because laying bricks requires skilled labor and more time than some modern alternatives, and it was increasing in cost. And finally, bricks is a heavy weight because their substantial weight necessitates more robust and costly foundation. So next, the application of bricks. Bricks are usually used in building walls because bricks due to their strength and durability. They provide excellent insulation against temperature fluctuation and can withstand harsh weather conditions. And then, bricks also being application in paving because bricks are commonly used in paving walkways, roads, and patios. They are interlocking nature, provide durability and resistance to wear, making them ideal for high traffic areas. And then application of bricks is a facades. A brick facades enhance the aesthetic appeal of buildings. Decorative bricks in various color and texture are often chosen to create visually striking exterior. And then the innovation of bricks. The first innovation of bricks is the incorporation of waste material because the use of waste material like limestone powder and construction and demolition waste in brick production has been shown to enhance the mechanical properties and reduce water absorption by bricks, making them more durable and eco-friendly. Next, the sustainable brick production by creatively replacing cement with limestone powder and natural aggregate with construction and demolition waste. Researchers have created bricks that meet and exceed the performance standard of conventional bricks. And lastly, the innovative brick design, which recent development in brick design and manufacturing have led to the development of bricks that are lighter, more porous, and more insulating than traditional bricks, contributing to better energy efficiency improvement. So that's all for me. Thank you.
Oh, thank you for the information.
Welcome.
That's all. Bye-bye.
What you looking at?
I'm thinking about how do these products manage to stick?
Because this is cement, it acts like chemical binder, like glue that usually used in construction site.
Oh, can you explain more about this?
I know the guy.
Who? Who is this?
This is Tuesday. Can you explain more about cement?
Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to talk about the cement. What is cement? Cement is a binding agent used in construction that starts as a finely ground powder. The most common type is Portland cement. It's made by burning a mix of limestone and clay. Cement are finely ground powder that when mixed with water through hydration to stick material like sand and aggregate into strong, durable structure like concrete and mortar. So, what are the physical properties for the cement? For the fineness, it's a finer cement hydrate faster, gaining strength, force quicker. Secondly, strength, compressive, tensile, and flexural strength, vital for structural integrity. Third, soundness, ability to maintain volume without delayed expansion like shrinking or cracking. 4. Heat of hydration, heat released during the chemical reaction with water. 5. Specific gravity, density relative to the water like mass over volume. Bulk density, mass per unit volume accounting for air spaces. Today I'm going to talk about the cement test. Firstly, we're going to talk about sounded test of cement by Le Chatelier apparatus. This test requires split cylinder, glass plate, and a weight. This test used to find the excess of the length of the lime in the cement. So firstly, we need to prepare a paste by adding 0.78 times the water required to give a paste of standard consistency. Secondly, we need to lightly oil the Le Chatelier mold and place it on the lightly oiled gas sheet. Cover the mold with another piece of lightly oiled glass sheet and place a small weight on this covering glass sheet. Submerge the whole assembly in the water at the temperature 24/7 or 20 Celsius and keep there for 24 hours. Remove the whole assembly from the water bath and measure the distance separating the indicator point to the nearest 0.5 mm and name it as L1. Repeat step 5 and 4 with the same assembly but using the boiling water for 3 hours and cool down in the room temperature. Measure the distance between the two indicator points to the nearest 0.5 mm and name it L2. By using L1 minus L2, we can find the soundness expansion of the cement. So we can conclude that standard specification that the cement must not exceed 10 mm for ordinary, rapid hardening, and low heat Portland cement. So, secondly, we will talk about the second test, is determination of a specific gravity of the cement. Specific gravity is defined as the ratio of the weight of a given volume of cement to the weight of an equal volume of water. The specific gravity of the cement can increase and decrease depending on the moisture of the content. The specific gravity of a standard Portland cement is 3.15, and any changes in this cement will have impact to the mix design. For this test, we need the Le Chatelier flask, cement sample, weighting balance, and kerosene. So firstly, we need to clean and dry the Le Chatelier flask thoroughly and record the Le Chatelier as weight 1. Fill the flask with approximately 50 grams of the cement and place the stopper at the flask. Record the weight and taken as W2. Add 24 ml of kerosene in the flask. Rotate and gently shake the flask to avoid air entrapment. Do it until all the air bubble has been removed. So, record the final volume reading in the flask as W3. The flask is emptied and filled with 24 ml kerosene and placed in the stopper. Record the weight as W4. So we can calculate the specific gravity of the cement by using this equation. So, value 0.79 gram per cubic centimeter is the specific gravity of kerosene. In general, the specific gravity of a cement is between 3.1 until 3.19. If the specific gravity of the cement is greater than 3.19, we will conclude that the cement is not produced with adequate fineness, or the cement will contain more moisture. That's all for me. Thank you for watching.
Do you know the advantage and disadvantage of cement? Okay. The advantage of cement is strong body material, which is cement can bind sand, aggregates, or other material to form mortar or plaster. The second one is cement is highly versatile, which is used for mortar, grout plastering, skim coat, and bricklaying. For the next one is cheap and widely available, which is it means cement easy to find and more affordable compared to many other bending material. And fire and heat resistant is advantage of cement too, which is cement does not burn and provide good protection against heat. And the last one is easy to mix and apply, which is cement only needs water to activate, making it simple to use on construction site. Next, disadvantage of cement is high carbon dioxide emission during production, which is means cement manufacturing is one of the major contributors to carbon emission. The second one takes time to set and requires proper curing, which is without correct curing, the cement becomes weak and cracked. Third one, very sensitive to water ratio. It means when we put too much water, it will be weak, and when we put too little water, it's hard to mix, which is it needs strict control. The next one is storage issues. It is cement absorbs moisture easily. If exposed to humidity, it will harden and become unusable. And for the last one is low strength and its own, which is pure cement is not used as a structural material. It needs sand or aggregate to regain real strength. Application of cement in Malaysia is building construction. Cement used in concrete to build house, apartment, and office building. Mortar for bonding bricks, plaster for walls and ceiling. The second one is interior housework. It's used for concrete flooring, screed to level the surface before installing tiles. The last one is repairs and maintenance. It's repairing concrete cracks. Now I will tell you about innovation of cement. Innovation of cement is recycled material cement, which is cement incorporating recycled concrete powder, glass powder, or construction waste that can reduce and fill waste and promote environmentally friendly construction. The second one is 3D printing cement. Special cement-based materials are developed for construction 3D printers, allowing faster and more efficient building processes. And for the third one is geopolymer cement, made from industrial waste such as fly ash or slag instead of limestone, that can produce far less carbon and has high durability. And for the last one is low carbon cement. New type of cement replace part of the clinker with material like calcium clay, limestone, fly ash or slag. This reduces carbon dioxide emission during production.
Oh, I see. Thank you, Tuesday.